Hi, my name is Caroline Butler, and I'm going to be applying for mentoring for 262 Organic Chemistry. So we are going to be solving a Diels Alder problem. So you first have your diene, and then you have your dienophile, and in this problem we will be solving for the product. So with Diels Alder, it is always going to end up with a hexagon for your product. So now you just have to figure out how everything else is oriented around it. And in your hexagon, you will also have this double bond right here every time. So let's look at the patterns of the dienophile first. So we can do an example problem to start us out with something easier. So we will have a simple diene, and this will be dienophile. And you'll start off with your hexagon and your double bond. So now, because your diene is just plain and simple as it always is, we don't have to worry about that. But your dienophile has two substituents sticking off of it in the trans form. So in trans, in your dienophile, it will also be trans for the product. So you will just have a dash and a wedge, and that's it. Now if your dienophile is in the cis form, then your product will look like this. With two wedges or two dashes. So just remember that you're also going to have your enantiomer. As well with your product. So now we kind of know how the dienophile works and how that's going to look like in the product. So now let's look at how the diene can change. So if you have a diene that looks like this, this is a little different than what we were looking at before. So now this one has substituents. We'll just do cis for this one. So now you have to figure out how these substituents will look in your final product. So a cool trick that I learned when I took it with Dr. Moy was IWAD. Inside wedge, outside dash. This one is the inside, this one is the outside, so that will be inside wedge, outside dash. So let's see how the product will look. We know that it's going to be cis for our dienophile, so we'll just do dashes. So now because this is our inside, it's going to be a wedge. We'll go right here, and this is our outside, so it will be a dash. And that's what our final product will look like. So now that we know how to deal with the diene and dienophile, we can go back to our original problem. So with the diene, right here, this is both inside and they're connected, which means in our product we're going to have something called a bridgehead. The way that you draw it, you will draw it with wedges, and I just like to draw it really dark to show that they're wedges, and you draw it something like this, as good as you can get it. And that will be for your diene. Now the dienophile is just in cis, so now we have to make the decision whether we are going to have wedges or dashes for our dienophile. For this, in Dr. Moy's class, she always wanted us to have the endo product. So to get the endo product, we want to have dashes. And the reason for this is that there's less sterics, because if we were to have wedges, it would be on the same side as our bridgehead, and that would just create more sterics. So we are going to do dashes instead, and that is our product. It's also important to remember, if you have something, a dienophile that is like something like this, with this, you're also going to use the endo rule. So let's just do a normal diene. So your final product is going to always have the substituent that is most electronegative face down to be the endo product. So you're going to put it on a dash. And that's your product. I hope this helped for figuring out Diels Alder. See you next time.